and development are the pivot of any developing nation. The Material Science and Technology Society of Nigeria are at it again, having its 20th annual and international Congress, tagged NEMACON 2021. You will be watching presentations of sterling researches carried out by scholars in Nigeria and diaspora. These researches were aimed at ameliorating poor science-based footprints in Nigeria and confronting some challenges bedeviling the material development and utilization in Nigeria. Stay tuned.
As batteries, then we have also include electromagnetic interference shield. This application is popular within the military community applications. We have the anti-static and anti-corrosion. They also be used as the photocatalyst. There are wide range of applications of conductive polymer and composites. Now, the methodology. The nanoparticles, we synthesize 2 nanoparticles, that's the 5% copper drop and 15% copper drop by way chemical method in ethanol distilled water mixture at 80 degrees for 3 hours. After the synthesis, the product was washed with distilled water and calcined at 300 degrees for 2 hours. Now, for the synthesis of the tanning and the nanocomposites, the method that was used was called the interfacial polymerization, which involves 2 different immiscible solvents, that is chloroform and distilled water. Chloroform being the organic, being an organic solvent, while the aqueous solution of HCl being the aqueous phase. Now, in this synthesis, the chloroform was simply the aniline was prepared with the chloroform, while the nanoparticles and the oxidants, which is aluminum persulfate, were prepared with the aqueous solution, and both were mixed together and they form an interfacial. Being an immiscible solvents, the polymerization actually takes place at the interface of where those 2 solvents meet and go on for polymerization to place for 12 minutes at 0 degree centigrade. Then this is the characterization, result and discussion. The figure A shows the absorption spectrum of doped and undoped nickel oxide in comparison with the standard nickel oxide nanoparticle. The figure B shows the Vanguard plots of the 5% copper doped nickel oxide nanoparticles, while the figure C shows that of 15% copper doped nickel oxide nanocomposites. Now, the Vanguard summary is, that's the Vanguard summary. We have the commercial, which is the standard, the bench nickel oxide, the Vanguard was 3.94 EV, while that of 5% copper doped nickel oxide was 3.45. When the doping was increased to 15, it decreased to 3.25 EV. Yes.
We've noticed that in recent times, especially in the 21st century, there's been an increasing interest by polymer scientists in the synthesis and fabrication of nanocomposites in order to improve the properties and extend the functionalities of conducting polymers. But this work basically is focused on comparison and contrast of the nanocomposite, the effects of nanoparticles on the nanocomposite. Now we're comparing the effects of the simple nanoparticles and that of the compound nanoparticles. I'm talking about nickel, comparing that of nickel and nickel oxide and that of zinc and zinc oxide. Next slide, please. Now first, we have to synthesize the polymer. Polyaniline was synthesized from the aniline monomer using the oxidative polymerization method, where we dissolve the aniline in acidic medium, dissolve the oxidant, that's APS, in acidic medium, and pour them together rapidly at the same time in a third beaker. This is known as the rapid mixing method by K.Z. Zachariah. Now, this first, the amount of monomer used was, we used 0.2887 grams of aniline, again 0.3537 grams of APS. Next slide, please. The mixture, back, go back. The mixture is then left in a refrigerator for 5 minutes, a freezer for 5 minutes before effecting the rapid release. This was just to try to bring down the entropy of the system, trying to replicate the Cooper-Payne effect of superconductivity, the BCS theory of superconductivity. Afterwards, the synthesized material is brought out after 48 hours and washed extensively with ethanol and distilled water and left in the open to dry gradually. That was for the polyaniline itself. The nanocomposites. In preparing the nanocomposite, first, before effecting the polymerization, we introduce the nanoparticles into the solution of the aniline. First, before pouring them rapidly together to effect polymerization. Now, we did for each nanoparticle, we did 8 samples. Like for instance, for the polyaniline nickel nanocomposite, we introduced nanoparticles of 1% weight gram of the aniline monomer, the reacting aniline monomer. We use 1%, 2.5%, 5%, 7.5%, 10%, 15%, 20%, and 25%. These are 8 samples. We have 8 samples for each nanoparticle, and we are dealing with 4 species. For the 4 nanoparticles, which gives us a total of 32 samples to analyze.
And when these effluents are discharged into the environment, they cause a lot of health issues and also destroy the aquatic environment. And as a result, substantial effort has been given to in recent years to pursue proper management and disposal practice of this waste. And in our country, Nigeria, high-oil effluents and rubber effluents constitute a major challenge because they are the major cash crop of the country. And process preparation from this cash crop results of very voluminous production of very voluminous effluents which are indiscriminately discharged into the environment. They pollute the environment by causing serious depletion of dissolved oxygen, causing unsightly scene, foul smelling and disease-causing conditions, and degrading the water body and making it unsafe for the aquatic environment. And the people living around that area are also at risk of waterborne diseases. And as a result of this disposal, it also give rise to the evolution of greenhouse gases, such as methane and carbon dioxide. This is the last slide. Therefore, this effect also contributes tremendously to greenhouse gases emission. Next slide, please. And the practice of indiscriminate discharge of large volume of this effluent is wasteful in terms of resource utilization and also contradicts the present day agricultural policy of sustainable development. And this has resulted to the quest for beneficial uses for this agricultural waste, especially when this waste has sufficient valuable chemical components which are nutritive, fertilizing, and energetic that are usually lost by improper waste disposal methods. But if these wastes are properly managed, it will minimize their adverse effects while maximize their important effects. Please, the same slide.
Is U.S. and Kevin. I'm here to present a seminar on pericarpal corrosions. The pericarpals have lost ultrapass, no class and mainly inhibitor for both advanced stages in various mediums. The outline of the talk will talk about the corrosion, the justification of the study, and now all of you should know that corrosion is very important in the human endeavor. In recent years, some people have been using synthetic inhibitors. And the synthetic inhibitors is not good in our environment. It's not good in our environment. I decided to, you know that we have innovations. Now we begin to talk about a green inhibitors. And you see that our climate is changing. And the whole world is shifting away from all this non-renewable energy. And when we talk about non-renewable, we are talking about some chemicals that have effects in our environment. Now, when we begin to adopt the green inhibitors like this, and we discover that thing has less toxic. Now, my aim here is that if we are going to use the leaf extract we are gotten from the Utropa or Pericarpus sanguineus to substitute synthetic inhibitors. Based on this research, I discovered that it has a potential to retardate what pollution rate. Now go to the method. Go to just move to it. Now when we talk about the sample preparations, the sample preparation of the leaf extract, experimental plan and measurement and weight and characterization of samples using cell, the scan electron microscope.
Thank you. I'm Dr. Miriam Tembitope from the Department of Chemistry, University of Ilorin. I'm presenting a paper titled Microcrystalline Cellulose Derivatives from Corn Cob. So since we are asked to spend only 10 minutes, I'll just have, I took like 3 quotes from our guest lecturers yesterday. They said nations are said to be economically advanced or wealthy only if they are able to transform available resources into finished goods. So another lecturer also said yesterday that the greatness of a nation is often a reflection of how available resources are planned, managed, and utilized. But the problem, so from the presentation yesterday, so I was able to see that our thoughts, that is from our lab, is also the same as what the lecturer presented yesterday. Because the problem of a developing country like Nigeria is how we manage our resources, because we have abundance of resources, abundance of natural resources in our environment. But the problem is how to manage it. How do we process the abundant natural resources that we have into finished goods? We have not been able to achieve that. And then, so from one of the abundant natural resources we have is the plant waste, or maybe plant and plant produce. And we have seen from literature that the constituent of all plant waste is cellulose. That is the abundance of it, because most plants have about 60%. Even cotton contains 98% of cellulose. And this cellulose has been shown to possibly replace some other petroleum products in future, because of its, if you look at the structure of cellulose, it has OH, please can you go back? It has OH groups, and these OH groups can be functionalized to any other thing. We can have so many derivatives, ethyl cellulose, methyl cellulose, and so on and so forth. So the objective of our research is to gather so many cellulose containing waste, then we analyze the cellulosic content, then to know the quality. Do we even have any quality cellulose in our environment at all? So why do we not have to go out to import cellulose? Because, for example, as of today, I know that pharmaceutical companies still import cellulose when we have abundance of it in our environment. So, can we move on, please? So going to the method, because of time, we isolated cellulose using acetic acid, that is alkaline pretreat method, using acetic acid, sodium hydroxide, and hydrogen peroxide. We know all these reagents are common reagents, and they are so cheap, so we can use it to, to process our cellulosic waste to get the cellulose we desire. Then the next thing we did was to increase the surface area of our cellulose. That is because we know cellulose has the amorphous and the crystalline region. So we had to break down the amorphous region to get the crystalline region in order to be able to get microcrystalline cellulose, which is also a derivative of the cellulose for further applications. Please, can you move on? Okay, this is just a process of preparing the microcrystalline cellulose. So we then subjected our microcrystalline cellulose to some tests, like the pH measurement, because of course we used acid to prepare microcrystalline cellulose. So we wanted to verify if we had actually removed the acid to a neutral pH. So we washed several times with ethanol and water also. So after drying, we poured water, we soaked it overnight. So after then, we tested the pH and we're able to get a pH between 6.3 to 7.0. And that is the standard of a neutral cellulose, as we have found in literature. Please can you move on? Then we checked for the starch content also, because we must be sure that our cellulose is free from starch, because cellulose and starch have the same structure, but the only difference between cellulose and starch is an alpha polymer of glucose, while cellulose is a beta polymer of glucose. So so we have to test whether probably if we have starch, because if you carry out FTIR studies on our cellulose and starch, we get the same functional groups.
My name is Onaifo Joshua. I'm here to present a paper titled Effect of Co-pyrolysis on the fuel properties of coconut meat and soft seed bio oil. Next slide. I'm going to be discussing that in the following outline. Next slide, please. Pyrolysis is the thermal decomposition of biomass in the absence of oxygen, while co-pyrolysis is also the thermal decomposition of more than two biomass in the absence of oxygen. Biomass is mainly composed of cellulose, lignin, and hemicellulose. The decomposition of this composition of biomass leads to the following products: the biochar from the lignin, the bio oil from the cellulose, and the biogas from the hemicellulose. Next slide. Pyrolysis can be broadly divided into two. We have the fast pyrolysis and the slow pyrolysis. The difference is in the heating rate. Fast pyrolysis requires high heating rate, high temperature, low residence time. And the product is mainly biogas. While slow pyrolysis involves the use of low heating rate, low temperature, and a high residence time. And the product is mainly biochar because of the time, residence time difference. No, go back to the slide. Pyrolysis mainly depend on the moisture content. Low moisture content of pyrolysis basically yields biogas. Next slide. Next slide. Pyrolysis reaction. Optimal pyrolysis temperature range between 500 to 800 degrees centigrade. And we have broadly two main reactions. We have the primary reactions and the secondary reaction. The primary reaction involves the production of biochar and the gas, while the secondary reaction involves the interaction of this product forming the primary reaction. Generally, the carbonization of carbonization occurs at a temperature between 400 to 600 degrees centigrade. Next time. The products are made biogas, which is non-condensable vapor, the bio oil, and the biochar. Next slide. The objective of the study is to generate and analyze bio oil from cocoa, and canola via slow pyrolysis. Next slide. Materials and method. This is my sample coconut meat and salsa. Next slide.
Paper titled Filtration and Microbial Removal Studies of Blended Point-of-Use Porous Ceramic Clay Copper Non-Particle Standardized Water for Water Purification. These are my outlines. Ceramic water filter. Ceramic filter is an inexpensive and constructible type of water filter that relies on the pore size of the ceramic material to filter depth, turbidity, and color out of water. It is basically a mixture of clay, sawdust, and water molded and fired in a furnace. the sawdust material burns out at around temperature of about 400 to 500 degrees Celsius, creating pores. The effectiveness of ceramic water filter in the production of a safe drinking water has been proven by many research papers, and these are some of the type of ceramic filters. We have the frostrum shape, the candlelight one, and the disc type. Nanoparticles. In the course of our increasing understanding of the effect of water quality on health, standard for drinking water has been revised several times. In this course of evolution, it is possible that contaminant concentration will reach molecular limit. That is the limit at which the most health risk will become a few molecules or atoms or ions per glass of drinking water consumed. As a result, the technology to remove these contaminants must also reach molecular limits. There must be highly efficient molecular capturing agents that could trap them during a single encounter at room temperature. Therefore, in strategizing an efficient molecular mechanism for the purification of water, nanotechnology, which is the study and investigation about the synthesis, characterization, exploration, and application of nano-sized materials will continue to play a vital role. A striking approach is the chemistry of noble metal nanoparticles, that is particles less than 100 nanometer in diameter, due to their large surface area, easy surface modification, and selective catalytic activity, making them an efficient adsorbent for water purification. In this paper, copper nanoparticles were synthesized based on the knowledge of its antimicrobial activity, and it was deposited by soaking in fabricated ceramic candlelight filter. The antimicrobial impact of copper nanoparticles is closely related to to the nanoparticle size, the minimum inhibitory concentration, and the oxidation degree at the surface. Therefore, copper nanoparticles will interact to release metal ions that interfere with the process of DNA replication, cell membrane formation, and cell division of certain microorganisms, thereby bringing about microbial impact. Methodology. Yes, the methodology, fabrication of ceramic candlelight filter. Ceramic candlelight filter was the red water clay, the white kaolin clay, and the sawdust were collected, pulverized, then sieved to finest particle sizes. Then the ceramic candlelight filters were fabricated by varying the volume composition of the clay, that is red clay and white clay, to sawdust in the ratio 55-45, 50-50, and 45-55%, while the ratio of red clay to white clay is 1:1, 2:1, and 1:2 respectively. Each carefully weighted quantities of the red clay, white kaolin clay, and sawdust were thoroughly mixed together with carefully determined amount of water pressed into the candlelight mold and fired in a furnace at about 800 degrees Celsius to 900 degrees Celsius temperature for 8 hours. Eventually, the filters were furnace cooled and then soaked in water for 24 hours for thorough saturation. Synthesis of copper nanoparticles. The copper nanoparticles used was synthesized by a chemical reduction method of copper sulfate pentahydrate by sodium borohydride, then alongside PEG, polyethylene glycol 6000, and ascorbic acid. A standard solution of each of the substances was prepared and thoroughly mixed together under continuous stirring until the reaction was completed. The result and discussion. This is the fabricated candlelight mold that was used to fabricate the candlelight filter. Then we have the graph of plasticity index against percentage sawdust. Now, in this work, 15 ceramic candlelight filters were fabricated, and then the plasticity, which is the property of a material to be repeatedly deformed without rupture when a force is acted upon it sufficient enough to cause deformation, which also allows it to retain its shape when the force has been removed, was calculated by Atabac plastic and liquid limit according to ASTM standard ASTM D4318. So there we We have the result of the plasticity against the percentage sawdust in each blended mixture sample. So here we can see that the PI decreased with increasing 40% of sawdust. When the sawdust was 45%, looking at the first sample, the 3-4 samples there. So there was a decrease from 45% sawdust to 50, then to 55. Then the same thing applicable to all the samples. And in the samples, the purple, red, and the blue colors, there was a sharp decrease when the sawdust was 50% to 55%. So the first 3 samples above was for 1 to 0 blend of clay or red clay and kaolin, and they have the highest plasticity. While the last one, the green color one, is the red clay ratio here was red clay to kaolin ratio was 0 to 1. That means the samples with only white kaolin clay and sawdust in the mixture has the least plastic index. So this shows the result of the UV absorption spectra of synthesized copper nanoparticles. Several samples were taken during the synthesis of copper nanoparticles. The first sample that was taken immediately after the addition of ascorbic acid, giving a yellow coloration. The next sample was taken 60 minutes later, just before the addition of sodium borohydride. It changed the color from yellow to orange. Then the next sample, the third and fourth samples were taken 5 minutes and 10 minutes after the addition of the strong reducing agent sodium borohydride. Now from the graph, we will see that plasmonic absorbance only appear around 562 nanometer. 5 minutes and 10 minutes after the addition of the strong reducing agent, indicating the formation of small clusters of copper nanoparticles.
How is this today that came and were honored? One of our Senator Obin couldn't make it, and he said he was going to come today. So he has sent somebody down, and we want to honor him. He's filing this to honor him. But I want to place on record that the award that we have for our senator is Award of Excellence. It's not a fellowship award. The association has it as a rule that we cannot give our fellowship in absentia. So, but this is just an award of excellence. The society has recognized Senator Obina's contribution to his community, to his society, and he has a good message for us. So I want to take a 5 minutes break to perform this award. He has sent someone to receive the award of excellence on his behalf.
From the University of Ilorin, I'm representing industrial chemistry, department of I'm presenting on preparation of high-grade phosphoric acid from a Nigerian fluoroapatite ore for industrial applications and how we guided by the flowing outline. As we all know that Nigeria is one of the African countries that is endowed with abundant varieties of solid minerals. Despite this utilization of these minerals to aid the country's economy, industrialization has been far less explored. So this chart summarizes some of the Nigerian solid minerals ranging from cassiterite, fluoroapatite, kaolinite, etc., etc. As at 31st July 2021, the London Market Exchange Rate affirmed that raw fluoroapatite ore is equivalent to about $94 per ton, while the processed fluoroapatite ore of industrial grades is between $722 to $940 per ton. So as I've said earlier that Nigeria is one of the mineral resources, it's one of the African countries that is widely blessed with abundant variety of solid mineral. For example, the demand for high-grade phosphoric acid of industrial value in fertilizer, medical, and agro-allied industries cannot be overemphasized. Next slide. So, for example, phosphoric acid, which can be produced from a fluoroapatite or find wide array of applications in fertilizer, phosphorus chemicals in medicine. For example, in medicine, it is added as a polishing agent so as to prevent teeth from decay. It is also used in fertilizer in the production of DAP, that's a diammonium phosphate. So, before fluoroapatite can be used to produce a material of industry, it has to undergo series of routes, which could be by hydrometallurgical options, pyrometallurgy, biohydrometallurgy, or by electrolysis. For example, in hydrometallurgical options, it could be by leaching, precipitation, so much. For hydrometallurgy, it involves the use of a specific bacteria such as Theobacillus ferroxidans. Due to the intensive demand for pure phosphorus and phosphoric acid of industrial value and the global demand for the actualization of the Sustainable Development Goal 9, which is industry and infrastructure, that led me to think of developing a low-cost and eco-friendly technique for producing a phosphoric acid of industrial value from an indigenous fluoroapatite ore. And the aim of the study was to develop a low-cost and eco-friendly technique for fluoroapatites upgrading for industrial value additions. And some of the objectives are to characterize the fluoroapatite ore vis-a-vis the chemical as well as the morphological purity assessment. Also to evaluate the dissolution kinetics for the investigation of fluoroapatite ore by hydrochloric acid media, and finally to beneficiate the purified pregnant solution so as to produce a phosphoric acid of industrial grade. The fluoroapatite ore used for this investigation was sourced from Danji local government area, Jos, Nigeria. So basically, the experimental section was divided into two basic unit operations: leaching as well as beneficiation step. During leaching, a lot of parameters were considered vis-a-vis effect of concentration, effect of temperature, effect of particle size, etc. The purified pregnant solution obtained was used to produce a high-grade phosphoric acid of industrial value. This table shows the elemental composition of the raw ore, which is the fluoroapatite ore, which considers that the calcium was around 51.83%, while the phosphorus content in the sample was around 6.38%. And this is the morphological purity of the ore, which affirmed that the material was consist of fluoroapatite as well as quartz impurities. And this is the morphological assessment of the raw ore. So, as I've said earlier, that during leaching, a lot of parameters were considered: the effect of leachant concentration, temperature, as well as pressure. So, as the concentration, as displayed on the graph, as the concentration increases, the percentage of the whole dissolution also increases, and about 99.3% of the dissolution efficiency was achieved at optimal leaching condition. So the experimental data obtained at optimal leaching condition was subjected to strictly commodity vis-a-vis the chemical dilution as well as the mixed control reaction, so as to calculate the activation energy. And the activation energy was calculated to be 24.3 kJ per mole, which supported the dilution control reaction mechanism. And this is the XRD of the residual product that was achieved at the optimal leaching condition, which truly supported that what? There are about 99.3% dissolution efficiency. This is the same of the residual product at optimal leaching condition. In conclusion, the result of this study provides valuable information on the leachability of fluoroapatite mineral in hydrochloric acid media. At optimal leaching condition, about 99.3% of the initial 10 grams per liter of the fluoroapatite was dissolved. And finally, a classical hydrometallurgical scheme for the production of phosphoric acid and separation from other associated gangs with use of high phosphoric acid that can stand for further fertilizer and medical applications was proposed. Thank you for listening.
And I'm from the Department of Industrial Chemistry. I'm here to present to the audience a research work titled a novel method for production of alpha hematite powder using thermite aid for utilization in magnetic sensing and catalysis. Before I move ahead, I would like to quote from the Holy Quran, where Quran 37 verse 18, where Allah says, "Until when they came upon the valley, and the hand said, Oh hands, enter your dwelling, that you will not be crushed by Solomon and his soldiers when they pass in." The hands here are determined, and they are dwelling in the termite cave, where they perform all other activities. And due to physiological and other activities by the hands, they build a mansion, they build skyscraper called termite cave. And the composition of this, some of these termite cave has been utilized in many activities such as fortification for making concrete. They also make use of them as an adopted to remove heavy metal and to remove effluent from waterways. Not only this, they also use in many activities such as road maintenance, road construction, bridges construction, etc. Used in synthesizing some other inorganic chemicals such as alpha hematite, hematite, and etc. Based on all these metallic oxides are magnetic in nature with different structures and different magnetic properties. And because of this, they are used for many purposes such as biosynthesis, drug release, etc. Iron oxide, as one of metal oxide that can be gotten from termite, consists of three forms, and the form include the magnetite, and the hematite. And application of hematite include catalysis, durability for pigment and coating and hemoglobin, and also in the medical purposes for catalysis and the treatment and therapy. The target of this particular study is to synthesize an iron oxide hematite from termite using hydrometallurgy through leaching and cold calcination to get the final product.
As we all know, corrosion is a natural process, and together with some of the artificial factors which accelerate the corrosion process includes in the coastal region like acidic waste and biological, chemical and human activities. These factors affect and degrade the marine infrastructures, and in most of the developed countries like the US, the cost of the corrosion is amounted to 2.4 billion. So therefore, developing nations like Nigeria should avoid this costly repairs by utilizing the local resources for corrosion control. And by the statement of the problem, as the case of this study, the Nigerian Navy is on daily operational services and aggressive marine environment, which have been noted to accelerate the decline in the material state of the ship. So over this year, due to negligence, there is less turnaround maintenance, like chipping and painting, which consequently the deck system is affected by corrosion, and rainwater start to seep inside the ship, therefore causing damage to some of the essential system to the ships, which need urgent attention. And different preventive measures have been developed but was not successful, among which include anti-skid crop and replate, which double plating also creates additional unwanted weight, and also requires the removal of some of the essential fittings and putting them back, which create another problem on its own. So the aim of the study is to develop a coating using local raw materials like waste glass for corrosion control. The objective of the study includes sample collection from the dockyard and then development of the cotton and modifying it with the waste glass, then determining its suitability using the electrochemical analysis. So going by the literature, these are some of the literatures that have been reviewed, which proves that silica is an important additive or reinforcement in improving the properties of a coating to improve its mechanical properties to accelerate the adhesion. So this is the method that was adopted for the study, which includes the collection of sample, which is mild steel that was fabricated on top of the deck and used as a sample for the study. And then the collected waste glass was also scrubbed and lime, which to remove the contamination, and then it was subjected to the XRF analysis to determine its composition, and then surface preparation, which is important before coating application. This is to ensure that there is a proper adhesion between the coating and the substrate. And then the coating was also prepared as an adhesive by these raw materials, which includes polymer MEKP, which is act as a catalyst to accelerate the curing process, and the accelerator and colorant, which act as a cross-linking agent, and then waste glass was also added as a modification to improve its mechanical properties. Then the coating was applied using hand layoff method due to the lack of proper equipment. And then the sample was then subjected to a series of electrochemical analysis. So this is the highlight of some of the place for the study, the waste glass before and after the beneficiation. And this is the collected mild steel, which was called as per the ES machine specification. And this is after the beneficiation. And this was that was the effect code, which was modified with the waste glass. And that was coated mild steel after it was dried. Then, so the result of the study, the waste glass powder was subjected to EIS, was subjected to SRF analysis, and it was discovered that there is silica, the sample was rich in silica of about 71.20%, which is an important indication that due to the inherent nature of the silicate oxide, it can impact durability and improve its mechanical properties. And the EIS result for the study also indicates that the charge transfer of all the samples indicated that the waste glass sample have the highest frequency of 42.7 ohms, which signifies that there is less corrosion reaction in the sample. And then the board plots also shows that shows the simultaneous measurement of modulus of impedance with respect to the frequency. The higher the frequency, it signifies the less corrosion reaction, and the less frequency signifies the corrosion reaction, which is responsible for the charge transfer. So this is the SRF result for the study, which indicated that the sample was rich in silicon oxide, and this is the EDS.
I have some research aims and objectives of this research. The main aim of this research is to integrate plantain peel and oil palm fruit bunch fibers, OPF, which as types of agricultural waste organic residue, on the production of refractory insulating clay bricks for cane linings. The objective is, one, to characterize the raw materials and formulate different compositions from the raw materials, to run XSM analysis to determine the structural properties, to run the XRF analysis to determine the oxide contents, the oxide clay and the two agricultural waste materials. Then to introduce an alternative raw material for cane lining refractory insulating fire bricks production. Next slide. Introduction, you found that there's so much agricultural waste found in our country, Nigeria today, and most of all these waste are not being utilized. They are dumped everywhere. You have the plantain peel, you have the OPF, that is the oil palm fruit bunch fibers. They are all dumped. There are so many of them, but I decided to work on these two waste materials. So, and this waste actually can be converted to wealth, creation of wealth. And most of the insulation materials we have in Nigeria today, they are produced from organic pores, and these are organic pores. These are organic forming pores, because at the end of the day, they burn out to give you pores and therefore lighten your materials. So I said agricultural waste, these are water waste produced as a result of agricultural activities in Nigeria. And the insulation capacity of a material can be increased by generating porosity in the clay body. Then combustible organic types of pore-forming additives are most frequently used for this purpose. And we have two types of organic and inorganic. We have two groups: the organic and inorganic forming pores. These organic pores, they are the agricultural waste. Then the inorganic pores, you have the diatomite, the calcite, the vermiculite, and so on and so forth. But in most of these inorganic pore-forming agents are expensive. So you go back to the organic pores because they are being found everywhere. They are all waste generated from agricultural activities. Next slide. Then the materials and methods. First of all, the clay I use in this study, the clay has not been used before. It's a clay I sourced from Aba from Imo State. So I had to run the XRF analysis to determine the oxide contents of the clay, the oxide analysis. So I also run what we call the characterization of the clay, that is to determine the properties, both the mechanical properties and the physical properties of the clay. In my, the materials methods, the clay where I source it from Imo State, which I also source the agricultural waste too from Imo State, because this particular local government, that is where much of these activities, these agricultural activities, mainly palm oil production is being carried out in this local government. So there are a lot of them there. So, and as well, the plantain peel, there's a plantain plantation in that area too. So a lot of waste are being generated in that area. So what I did, sample collection, I collected the sample, I've told you the samples were collected. So I got these samples and I processed the samples. First of all, the clay is being processed. There is what we call liquefaction, the process of removing unwanted particles from clay, unwanted materials. We process it to refine the clay. Then I also process the agricultural material because we need to reduce the particle size. So I did that. Then after doing that, I went to the lab. The research was carried out in ceramics production department in Proda, in Nugu. So what I did was, like I said before, the clay has not been worked on. So I did what we call the 100% pure properties of the clay to determine the properties of this clay, to know actually if this clay is suitable for this clean lining production. So I now did variations in my the additives I was using. I did 90 for the clay, 5% for the plantain peel, then 5% for the OPF. The OPF is the oil palm fruit bunch fiber. Then I did the next specimen, which is C, 80, 10, 10, 70, 15, 15, then 60, 20, 20. The next slide. So these are the determination of the physical properties. I was able to determine the shrinkage of the clay, to know the shrinkage percentage of the clay. I did for the total shrinkage and the linear shrinkage. The next slide. Then determination of the apparent porosity. You need to know the porosity of the clay because it will actually help you in your end research. Next, I also did modulus of rupture, which is the tensile strength of the clay. Then next, then the refractoriness. As the formula I use for refractoriness, the Schon's formula 360 plus AL, the alumina content minus RO, all over 0.228. So after my application, I found out that most the clay mixed with the agricultural waste increase in terms of refractoriness, because any clay or any material that can withstand 1,000 degrees, above 1,000 degrees centigrade is a refractory material. So next slide.
From the abstract, we can see that the major physical properties that were tested are the apparent porosity, the apparent density, bulk density, per stage, water absorption, modus of rupture, modus of plasticity, the shrinkage, and then the moisture content. Next slide. From here, we can actually see the definition of clay, which is actually the fine material gotten and then mixed with water so that we can be able to get the plasticity. So that is that for. Then looking at this, how we want to get the physical properties just by clay resolution. So we dissolve the clay in water, and then from there we mix it up with the fluoride ion containing chemicals. Then from there we can be able to test and then know the physical properties of the clay. Right. The next one. So the sample preparation method, that's the methodology. The first thing we did then is to actually disperse it in a distilled, deionized water that is in a pre-treated plastic container. So after doing that, we have to settle it for 48 hours so that excess water can be able to be decanted. And then we also sun-dried it for several days across the sea that can remove the hard material, maybe the impurities or the stony materials inside. That's the sense of sieving. And after the sieving, we have to mold it into 3 different shapes and in a metallic mold. Then from there, we got our samples. So it's those samples that we now got that we then moved into the different, now started testing the different properties. So the next one. So we have the relative plasticity test as we use this formula, H0 over H1. Of course, this was the original height, that is H0. Then the H1 was the final, the deformation height. So then reflected in our results. We also did that. We also did the modus of rupture test using this expression here, where the B is actually the breaking load, the L is the distance between the support, and we have the B, which is actually the width, and then the H, which is the height. Right. The next slide. Then we also did the shrinkage test using these expressions, where the L0 is actually the original length, then LT, you can see it from there, the dried length. Then this one is also the final length, that is the LF. We did that for wet dry shrinkage, for dry fire shrinkage, and then for total shrinkage, all in percentage. Right, the next one. So we also did the water absorption test using this same expression for water absorption, where we have M1 to be the dry weight, have the M2 to be the soaked weight. After this, we got the results in the water absorption.
Students can always come and then slotting or swiping their card, and then attendance will be registered in the microcontroller. It's just a way of saving time, not cutting off the manual method of taking attendance by writing, manually and all that. For those of us in the core sciences, we discover that practical classes, some students can actually abscond from the practical class, and then in the name of they let me report their write their report and submit. This is actually used to ensure that the proper thing is done in the classroom, in our laboratory, in the library, and all that. Please, the slide, please. So the method we use, we used put to the block diagram segment. The block diagram, yes. So the block diagram here consists of RFID reader, a microcontroller, an LCD display unit, and also a macro SD card. What it does is that the student can actually come in with its RFID card, and then it swipes it on the macro RFID reader, and this sends signal to the microcontroller. And then from there, this student ID card or number or roll number is authenticated by the microcontroller and sent to the LCD with the liquid crystal display unit. And then if the student his number is already registered or pre-registered in the database of the microcontroller, the student will be granted access to the class. to the laboratory or to the library if it is used in such case. But if it is just the attendance system, as you swipe the card, the attendance will be marked in the microcontroller, and then the student will be registered as having attended the class. Next slide. So this is the full circuit diagram of that was implemented. Go next. Go ahead. So go back. So this is the liquid crystal display. This liquid crystal display is a 16:2 display unit. 16:2 in the sense that we have 16 column and 2-row display on this LCD. So if a student is granted access, it will be written. The LCD will write authenticated. Okay, it means that the attendance is registered in the database already. Next. So this is the SD card. Next.
To build the blast furnace, which I did with the engineer, if I came from Uganda. Yeah, Uganda. So that is the furnace. That is the furnace, where we produce all these materials. These materials. The inside in blast furnace. Like this clay they are talking of, use it to line the furnaces. So I made effort to test quartz and coke. I have coke, so I got quartz, this crystalline quartz. So when you feed it in the furnace at 2000 degrees centigrade, it will melt to give you silicon and CO2.
From there, can you extract for solar panels?
I'm coming to that. So, it gives me this material in the furnace. Fire. I have this silver line material. For me, this rice cup. For me, I can be further clean. Because this one is 99% pure. But you cannot do distillation. You have 99.99%. For me, I can always do the solar cell.
It's 99%.
Yeah.
99% pure what?
Metallurgical silicon.
Metallurgical grade.
Silicon. So from here,
you will refine this from the walls.
Yeah, no, this was and coke. Coke can be charcoal or wood. There's a special coke from we use in the other experiment. So when they burn at 2000 degrees centigrade, then they have this. You have this. It happens from the ground.
The walls, when you source it.
It's abundant in Nigeria. It's in Nigeria, it's local source.
And this one, when you source it.
This one I got it from somebody, I don't know, but if you go to Conga, they have it in abundance. You can buy it from them. Conga is a retailing store. It's in Nigeria.
Okay,
Conga, online. It's there, you can buy it.
That would have been good if you have.
So, for one question. Yeah, my outline of presentation. Yeah, I reflect upon porous carbonate material being used for effluent reduction or removal. The properties in process which enhance this high absorption capacity, and also we have high specific surface area and good surface chemistry. So not only that, but actually we have commercial applicable around us, but there is a very good economic benefit from manufacturing anti carbon from waste materials. Yeah, the following statement is there are a lot of before now Ibrahim et al. Works have talked about the prospect of avocado seeds, avocado fruits in the country, of raw material and so they said that they had potential of making 5 million naira from avocado fruits yearly. So this prompted this work. If we are going to be harnessing avocado fruits, therefore the seeds normally being disposed of as waste material. So we try to now see if we can convert these seeds into activated carbon for effluent reduction. The seeds are taken are gotten from the markets, treated and converted into carbons by carbonization at 400 for 1 hour to produce the biochar. Then the biochar are then activated at different concentrations of phosphoric acid. Then to produce the powder that was activated carbons. These powder avocado activated carbons were now characterized using iodine number and the yield of the activated carbon. So the iodine number and yield were now optimized using response surface optimization for different Castellian temperatures and different concentration of activating agents. So this we carried our approximate analysis using the ESTM standards, and this is how we evaluated the approximate parameters. Also the yield and the iodine number was evaluated using these two expressions. Then the performance of the activated carbon produced were kind of tested using Mercury blue at total capacity and also removal percentage. This is the boundary conditions for the CCD design of response of waste methodology. And this is the approximate results. It shows that temperature has a very high effect on both hash contents, volatile matter content, and also the fixed carbon from the correlation coefficient we have there. Hash content will increase with temperature, volatile matter will decrease with temperature, fixed carbon will decrease with temperature. Also, the same trend was observed for the effect of the concentration of phosphoric acid on the activated carbon. Then also, we have the correlation coefficient of iodine number and yield. If you observe very well, temperature has a higher effect on the yield with a 0.94 correlation coefficient. But iodine number, the concentration of the activating agent has a higher effect on the iodine number of the produced activated carbon. Then these are the ANOVA table for the empirical models developed. And you can see the models are significant, with very low value, T value, and the after model reduction and parameter elimination with model transformation, we're able to, next slide please, we're able to come out with the response of the yield as this. X1 represents the temperature, X2 represents the concentration of the iodine of the phosphoric acid used. Okay, next slide. The iodine number also has we obtained the empirical model for it, and if you observe very well from this control box, lower iodine number at low temperature ranges, lower iodine number, but at low temperature ranges, lower iodine number, lower lower concentration of phosphoric acid favors a high iodine number of alkylic carbon. But for high temperature ranges, higher concentration of phosphoric acid favors higher iodine number of the alkylic carbon. Then this is the scatter diagram for experimental results, experimental responses, and also the prediction of the models for both yield and iodine number. And we will see we use some error functions to evaluate the deviations of the model from the experimental results, and these are the values. The next slide, please. Yeah, the performance of manipulable adoption, we obtain the 136 milligrams per gram for the atomic capacity, and also which was equivalent to 90% reduction in the manipulable concentration at equilibrium. In conclusion, next slide. In conclusion, Avogadro Smith was successfully employed as professor for phosphoric acid activated carbon, and also based on central composite design, a linear and quadratic model were developed to correlate the independent variables. Then the optimization, we use RSM, we got the optimal range of temperature within 623 and 640, and also the optimal concentration of phosphoric acid as TRG was used to get optimal value of the calcine as 2623 degrees centigrade. Finally, a trade-off between lower activating temperatures and higher activating chemical concentration should be considered in optimizing the responses, the microparts of alkylic carbon. Then also the alkylic carbon showed a great absorption capacity, which is indeed 136 milligram per gram, and also which corresponds to 90% removal efficiency of the material. These are the references used. Thank you for listening.
Carbon sulfide in this state analysis. Like introduction, state analysis was used in this one to predict carbon sulfide in the aspect of what I did. And the technical, it involves spraying of aqueous constituted of desired compound to substitute to maintain the temperature of the single and this surface cosmology is divided into two aspects. We have the microstructure and the film. The microstructure consists of a spherical grain for higher local concentration, while the film consists of closely bound grains. In the aspect of this closely bound grain, we find out that the concentration of dopants increases with the film atom itself. And the image you will see in this film is an EM analog light microscope.
Section. It's unfortunately we are going to chair session. I'm going to be a part of the section. I'm doing excellent things. We are pushing the association system. Thank you very much. So we're able to come up with, from all of the deliberations since today. So we are going to read it out, make contributions, correct anything that needs to be corrected before we pass it on. So on this note, I want to call on our able Professor to come and read out the communique to the hearing of everybody. And if you have any contribution, if you have any disagreement with a particular section or otherwise, please feel free to say that. Because when we say the communique came out of this conference, it's binding on all of us who attended the conference.
Attention to every statement that is made there, and even if it's the construction of the statement, you can make suggestions. Because as soon as it's approved, it's going to be published and be distributed widely to those that are concerned, especially at governmental level. Materials Congress, NIMACON 2021, held at the Nnamdi Azikiwe University, Awka, Anambra State, between December 8th and 10th, 2021.
Chuka Nwoye, a professor of regenerative process evaluation and empirical modeling. Guess why we're here? This is NIMACON 2021, the 20th annual and International Conference of Material Science of Nigeria. Material Science and Technology Society of Nigeria. This is a period where researchers, scientists, technologists, they come together, rub minds, and then deliberate on issues on how some challenges bedeviling this country can be solved. A lot of things, a lot of activities took place. One of them is a technical session, plenary session, and award of fellowship to befitting Nigerians who have contributed so much in the materials, science, and technology. Thank you.
Professor Mrs. Esther Ihworia. I'm the president of the association, the Material Science and Technology Society of Nigeria. We have just concluded our 20th International Congress, tagged NIMACON 2021. It's been a wonderful time. You know, we have just concluded the communique from the Congress. Beautiful papers, enlightening papers were presented. And you will agree with me that all the participants enjoyed the presentations and they learned a lot. So we are actually imparting on the populace on materials development and utilization in Nigeria, because it is a key to economic advancement and sustainability. Okay.